In this one, we have the sum n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1, divided by 2n plus 1 factorial. Let's do the same thing. So it's really the same format as in the 2 sections ago if you include the review section. So you're going to look, if you want to apply the ratio test, you're going to look at that formula, an plus 1 divided by an, absolute value. So what does that look like? What's an plus 1 here? X to the, okay, remember if you plug in n plus 1, here you have to multiply out that 2 and then add the 1. What do you get? 2n plus 2 plus 1 is 2n plus 3. And then down here, 2n plus 1 again, so you plug in an n plus 1 right there, and you'd get 2n plus 3 again, wouldn't you? And then factorial on the outside. So that's just an plus 1. Okay, and then flip and multiply by an. What do you get? Just times, just look at this guy. Yeah, 2n plus 1 factorial on top. And then negative 1 to the n on the bottom times x to the 2n plus 1. Okay, now it's simplifying. Forget about anything for right now except using algebra to simplify. First of all, can we get rid of those factors of negative 1 to the power? Yeah, the absolute values split up over multiplication and division. You could bring them to the outside, inside absolute values, and then the absolute value of negative 1 to a power is just 1. So essentially, you can delete them, is what I'm trying to say. And then, so we'll do that in the next step, but we still have to keep the absolute values around because of the x to the power. We don't know if that's positive or negative. So still keep the absolute value around, and we have x to the 2n plus 3 on top, and there is a 2n plus 1 factorial left on top. And then I'll put the x to the 2n plus 1 underneath the like base. So this guy underneath the like base. And then how do I want to rewrite 2n plus 3 factorial? 2n plus 3, 2n plus 2, and then 2n plus 1 factorial, so I can do the cancellation. And then proofread that for me. Did I forget any factors? I got rid of the negative 1 to the power on purpose. I got this guy, I got this guy, I got this guy written out, and then I got this guy. So I think I'm good. Okay, any issues there so far? All right, let's simplify. So what do we get? Oh, this guy divides with this guy. And then what is x to the 2n plus 1 into x to the 2n plus 3? What's left? So what's the rule? You take this exponent, keep the base, subtract this exponent from this exponent. The 2n's go away. 2n plus 3 minus the quantity 2n plus 1. You're left with just a 2 in the exponent, right? So x squared. Does everybody see the math there? And then what's left? Let me put that x squared kind of in the middle, because that's all that's left on top. So x squared, and then what's left on the bottom? 2n plus 3 times 2n plus 2. And then we do still need those absolute values. So that's the simplified version of absolute value of an plus 1 divided by an. That's all that is. We still need to take the limit of that thing as n goes to infinity. Not as x goes to infinity, as n goes to infinity. So you treat x like a constant when you're taking the limit. So if x is a constant with respect to n, then the numerator is a constant with respect to n. And what's the denominator going to do with respect to n as n goes to infinity? It's going to blow up. It's going to blow. So you could do this. If you want to use the arrow notation, what is this guy going to converge to? For any particular x value, what does it converge to? 0. Doesn't matter what value you pick for x, eventually this will converge to 0. So, so is that less than 1? Yep. For all x. Should probably make a note of that. For all x. So what can you say about the series? So you could say the given series, if you don't want to write out the series, you could say the given series does what? Converges absolutely. I usually just use converges. But if you want to say it is true, it converges absolutely. For what? Now you want to, the context here is which x values does it converge for? For all x. That won't always be true in every example. So for all x, for every series that won't be true, but for this one it is. So the given series converges absolutely for all x. Well, if it converges absolutely for all x, what does the interval of convergence I have to be? We're talking real numbers, so yeah, if we write it as an interval, it's -infinity to infinity. In other words, this thing always converges. What would r equal? Infinity, yeah. Oh, now one thing I didn't mention in this, and this is why you proofread, so you find mistakes like this. How do I know this? What test am I using? By ratio test. So at some point, and I don't really care where you put it, you could say so by ratio inside commas, so by ratio test the given series converges absolutely for all x, or you could put it at the end. So it'll read, so the given series converges absolutely for all x by ratio test. Or by the ratio test, but I don't care if you include the article, the. Whoops, started spelling article. Because I was thinking of the as the definite article. The ratio test. Proofread it. So the given series converges absolutely for all x by the ratio test. That works. And then I listed I and r, and I think that's all we were asked to do.